Hey, Gerhard. Good morning from me and good evening to you.
Hello, Reed.
How are you doing today?
Good, good. How about you?
Doing pretty well. Thanks for joining back on. I think this is your, at least across both channels, your fourth time or so
Through the
doing a
course
live stream
time,
with us.
yeah.
Yeah. Yeah. Um, Usually they've been tool focused. So now I think we get to talk about more of like some broad fabric discussions, which will be good today. But I think from that perspective, at least, welcome back again. Appreciate you coming on to talk shop with some of the capabilities of the fabric ecosystem.
Sure.
And I think a good place to get started, as we always do, is for those either watching or rewatching the video later. If anybody's not too familiar with you, if you want to give a little background about yourself, kind of what you do, where you're coming from, we can start from there and eventually transition into the topic of the day.
Yeah, sure. So, yeah, my name is Gerhard. I'm from Austria. And I've been working with data and like data platforms for almost 20 years, starting back then with Microsoft SQL Server and like analysis services, reporting services, and all these kind of things, like building traditional data warehouses and BI solutions. And let's say for the last 10 years, more or less transitioning into this big data space where we are building analytical platforms in the Microsoft Azure cloud, basically. Foremost with Azure Synapse or Fabric nowadays, and as well also for using Databricks.
Yeah,
And
and you
yeah,
and as always, just as a reminder of like for people of like the first time that I ever came across you was back when you were doing like wizardry DAX stuff for as like a guest blogger when we were both doing blogs and stuff for PowerClip Pro like 10 years ago and all that. And
yeah,
you've obviously significantly branched out from the front end universe of like reporting into a lot more of the back end focus for sure. For sure,
yeah.
it seems
So
like you would enjoy kind of the um, more of the code focused type stuff when it comes to the figuring out how things work and then finding new ways to configure the gears.
yeah, I think that pretty much describes my my being, let's say. And yeah,
Yeah.
as you said, like my background is very much from reporting and like building analytical models at some point, like semantic models. Doing a lot of docs, also Power Query actually, which I'll also come to later on. Um, but yeah, in the last years, more focusing on like end-to-end implementations of data platforms, basically. But in general, I think it's just like technical challenges, and if I find a technology that's cool and that I like to dive into it and also involve myself in the community and other stuff. Um, so yeah, I think that's the most important fact about me. And I'll also
Excellent.
add some more information afterwards when I introduce myself on the slide. So
Oh yeah, sure. Yeah, if you want to as well, just speaking of slides, we can throw that up if that has some additional context to kind of segue into the topic of the day.
yeah, sure.
Excellent. Let me throw that up. Here we are.
Yeah, so yeah, today we're talking about Delta Lake and a storage format, storage protocol that's used widely across, especially the let's say Microsoft Azure data stack, which includes Fabric, Synapse, and Databricks as well. Oh, sorry, my Teams is still. Give me a second. So sorry for that. So here we go. Um, so where was I? Yes, yeah. So
Yep.
yeah, working with Delta Lake on Azure basically, and the way I got into Delta is when we were building like a solution for one of our customers back in I think it was 2019 or so when Delta Lake just came out. We we had to try it, and I was initially super impressed by it, and still am. I think it's a great technology, and I was super happy when also Fabric and Microsoft jumped onto the let's say Delta Lake train because that was some kind of like my home turf already and now I have like Delta Lake in my favorite data platform, which is just amazing, right? Yeah, and today I'm just talking about some things, how Delta Lake works, what actually happens under the hood when you do like run certain operations, and yeah, give you some insight and on features of the Delta Lake that you might not be too familiar with, but that are very powerful and can be used to build really great architectures. Okay, so yeah, again, like as I said, quick introduction about myself. So as mentioned before, working with data platforms for almost 20 years, being Microsoft MVP, also in data platform for I think 9 or 10 years. Yeah, I'm blogging and being active in the community as well on Twitter and on LinkedIn, or post topics related to like Fabric and Databricks as well. In my free time, I like to develop VSCode extensions, which we already had some sessions on about like Power BI Studio. I think we did some time back.
Yep.
Yeah, so like Fabric Studio and Power BI Studio, and also I built the Databricks Power Tools for Pico, for the company I'm working for, to basically interact with Databricks from VSCode. The most relevant contribution when it comes to open source, though, especially for this talk, is the Power BI connector that I've built for Delta Lake back then when there was no official connector from Microsoft yet. And we might also dive into that a bit. Yeah.
And I'll drop a link to the in the chat to the live stream that you did on the Fabric and Power BI Studios.
Yeah, cool. Yeah, and yeah, in general, I'm working at a company called Pico, where we're building like data and AI solutions for our customers, mainly in the German-speaking areas, but potentially also abroad. So if you're interested in that, yeah. And also, I'm actively contributing to the data community in Austria, where we also host a data Saturday once a year, usually in January. And yeah, so that's about me. Let's have a brief look at the agenda and what we're going to talk about in the next hour. So general overview on what Delta Lake actually is, and also how I got into Delta Lake and basically the history of Delta Lake. Then jumping directly into the Delta log, like the transactional level on top of Delta Lake and on top of the actual data. And dive into how this actually works and how the data is stored together with the log and how this is managed. So from a very let's say deep level, so that you really understand on a transaction level what happens when you run like an update statement, because it might not be as intuitive as you might think. Another important stuff is the whole file and storage management, because like at some point we're storing data, and Delta Lake likes to store redundant data. And if you don't know what you're doing, you might end up with a huge bill because your data volumes just grow. So that's very important. And then I'll highlight some features like streaming, change data feed, and also give some updates on what's coming in the next releases of Delta Lake. Okay, so yeah, what is Delta Lake? It's basically Delta Lake is an open source storage format framework that enables building lakehouse architectures. What does it actually mean? So when we've built the lakehouse or big data architectures in the past, we were used to use Hive, the Hive Metastore, to basically store our data and make it accessible by a SQL. But in the end, like the Hive Metastore was basically just like a shortcut to reading a set of files that reside on a storage system. Whenever you wanted to like update some data, you basically had to rewrite some files, then something might have gone wrong and only like half of the files has been written, then the data was inconsistent, and so on and so forth. What Delta Lake adds is ACID compliant transactions, so that more or less guarantees that the transaction is executed as a whole or not at all. So like if you get an error, you basically fall back to the previous version of the table. or all operations that you did are basically committed and are accessible in the new version of the table. Another very important feature, which was the main reason for me back then to switch to Delta Lake, is the support for update and merge. So instead of having to rewrite files manually in the Hive meta store, we can just basically run an update or a merge statement on the existing data, and Delta Lake handles everything about the asset compliant transactions, etc., for me, and I don't really have to care about it. Which is
exactly.
Like from a data engineering perspective, that's like pure gold, right? Another feature that's really nice, but it's actually just some I wouldn't say it's not leftover. It's just some that comes with the way how Delta Lake is built is time travel, so that you can basically jump back in time in your table, like temporal tables in SQL Server, and say, okay, I want to see the table how it was like 5 hours ago or 3 days ago, etc. Which can also be quite convenient if like your daily load fails and you say, okay, only parts have been loaded, you can just roll back certain tables to the previous timestamp, and then you still get like a consistent state across your lakehouse.
Two things on that. One, I just want to comment on like the time travel feature. And one, if you can just click the little hide button bottom center next to the screen share. Perfect. Yeah. Like I'm hoping at some point, and I'm sure it will come someday, but like the ability for the report layer in Microsoft to be able to access that like from a versioning perspective, because I'm sure you've probably done this before for clients where you have to build out a specific table that has actual version history, but it requires like special modeling to do that. Being able to just have that exposed automatically, for so many clients would be amazing just to literally like go back to any moment in time to see like, oh, what's my percentages of sales stages or whatever the metric might be. It's not just a refresh, but it's like, I want to know on January 15th, what was my data like? Because the data is available, it's just not exposed yet downstream to the like Power BI as an example.
Exactly. Yeah.
But like in a future vision, I'm hoping something like that does come out someday.
Yeah, one would think that with Direct Lake, that's pretty straightforward, but it's probably not.
Yeah, I'm sure there's always extra
like,
complexities yeah, exactly.
Yeah. So that's a really cool feature. It can be really handy at some points. Another was the schema enforcement and schema evolution. Like if you have like a changing data source it constantly adds like new columns, for example, like schema evolution can be really nice. Because you don't have to maintain the state of a table or the structure of a table, and you can just use like schema evolution to automatically add like new columns, for example.
Yep.
Also super cool. Everyone knows about the batch processing capabilities of Delta Lake. So like you have like a daily job that loads a specific set of data and transforms it into Delta Lake and stores it as a table. That's like a very basic feature. But you can also use like streaming. So each Delta Lake table can be used for streaming. So you can stream from a Delta Lake table into another table. And also you can write a stream into a Delta Lake table. So this allows you basically to build like really cool streaming architectures where all this hassle of knowing for each individual table what has already been loaded, what's still missing, etc. Especially like if something went wrong in the daily load. To not reload the same data twice and stuff. So they're pretty cool built-in capabilities with Delta Lake streaming. Yeah, it's 100% compatible with Spark. That's from I mean, it still is obviously, but nowadays there's also like integrations in Rust and Python and all kind of languages, and it's also like the whole ecosystem around Delta Lake is just growing. The support for Polars, for DuckDB, and all those single node processing engines. So there's a really wide adoption, which is great for Delta Lake in general, right? Yeah. So what is Delta Lake actually? So it's basically your data stored, and usually it will be like a blob store or some cloud storage, can also be S3. but it could also be like your local storage system. Okay, so you can also have like a Delta table residing on your C drive, for example. It's basically just a predefined set of folders and files under one common root folder, where you have like stored the metadata, which is like the table structure, basically, the individual transactions, the transaction log or the Delta log, and the actual data. The actual data is stored as a bouquet file. So columnar, compressed, and highly optimized for analytics, basically. Technically, you can just like take that table and copy paste it to wherever you want. So it's like encapsulated, and it's kind of like self-contained.
Mm-hmm.
Yeah, whenever you access a Delta Lake table from Fabric or from Databricks, basically what you do is just pointing to that location where that table resides. There might be some additional caching, whatever, in Unity Catalog, in Databricks, or in Fabric. But in general, that folder, that location has all the necessary information to read the table and get the metadata and structure out of it.
And you might be getting into this too, like at a future slide, but I do like that there's the now in preview option in Power BI Desktop to like allow storage of even the semantic models in that format, where you can actually do direct link against just a regular semantic model. It doesn't have to be in a warehouse, lakehouse. It can just be a typical Power BI model, but still store it in the same structure to use in other upstream sources or item types.
Yeah, I'm not covering that, but yeah, that's true. So with the latest release in Fabric, you can do that. You can just access any Delta Lake table regardless of where it's stored. I think it still has to be stored on one lake, if I'm not mistaken.
It does.
It doesn't matter whether it's like a shortcut to Databricks or to S3 or to whatever.
Yep.
Yeah, just a brief history of Delta Lake and where it came from. So initially, like back in 2017, it was just proprietary to Databricks. And at some point, they partially open sourced it to the Linux Foundation in 2019. And by 2022, they fully open sourced it. And nowadays, all the features that are available in Databricks, for example, are also available in the open source version of Delta Lake. There might be some newer features that are only on Databricks yet, but they will all sooner or later be also available in the open source version. And Databricks actually focuses more on capabilities around managing Delta Lake tables and not on the so the Delta Lake protocol itself is fully open source. However, it's still like the original creators were from Databricks, and still the development of new features is still very much driven by Databricks. So yeah, as you can imagine.
Exactly.
For my history with Databricks and also with Delta Lake, so I basically, like, as soon as Databricks was available in Azure, I like tried to get my hands on it and also kicked off my first project with Azure Databricks in 2018. We did like exactly the journey that I mentioned before, like having traditional Hive meta stores with a regular storage account underneath, where you like replace partitions to make sure you not end up with inconsistent data, etc. And then, like, when 2019 Delta Lake emerged on Azure Databricks, we used it, but mainly for the reason to be able to use the merge statement. Back then, we didn't really know what it was, and we just like give it a try, and it worked out pretty well. And yeah, over those days, I collected a lot of experience at Delta Lake. And one of the issues back then that we had was that whenever we wanted to like read a Delta Lake table into Power BI, actually, we had to have a cluster running. So back then there was like no serverless SQL warehouse or anything. So it was pretty like complicated, but kind of complicated to get data into Power BI, because you had to start the cluster up front, start your refresh, and then shut down the cluster again, and these kind of things. So it was quite a hassle. And
I was gonna say, was it like overall on the tipping of the scales? Was it like effort versus payoff? Was it kind of like between the two of them, or where was the balance of that, would you say? I like that you have to think about this too a little bit.
I mean, it wasn't really feasible. I mean, it worked, but it wasn't a good solution, right?
So
And
I paraphrase, maybe more of a learning experience than anything at the time, just to get familiar with the system.
yeah.
That's fair.
So yeah, yeah, after all these endeavors, I wanted to like find an easier way to connect Power BI to a Delta Lake table. So I already knew like how Delta Lake was built with transaction log and some JSON files and Parquet. And then at the end of 2022, I think Power BI introduced like a Parquet reader, and then I basically had all the information or the tools available to basically read a Delta Lake table in Power BI by parsing the Delta logs and accessing the data. And so I built like the Power BI connector for Delta Lake. And also contributed it to the official repository, to the Delta Lake repository. I think like 1 or 2 years ago, Microsoft finally decided to build their own connector for Delta Lake because well, it's pretty fundamental to Fabric and to their data platform. So yeah. Yeah, then onward, I was like just very active on Delta Lake Slack. That's maybe a shout out. So if you have like any questions on Delta Lake, there is a Slack channel. It's a link in the very end of the presentation. I'm still very active there, and it's a very good place to get to ask questions, and also usually get very good answers because most of the contributors are just active there and like just answer your questions. And yeah, like
it's nice when you can get those quickly. Go ahead.
Yeah, that's like Slack is amazing for that. And yeah,
one reason I'm happy about that group. Go ahead.
Yeah, just like since then I'm speaking on meetups and these kind of things, and like kind of like implementing projects with those technologies and Databricks and Fabric for my customers. Okay, so let's dive into the Delta log and what it actually is. It's basically like a bunch of JSON files and checksum files, but I guess I can ignore them for now. And like those JSON files contain all the information, all the metadata basically of your Delta table. So the schema, the table schema, what kind of columns you have there. If there was a schema change at some point, some metadata and metrics, like some statistics on what columns, how many null values are in there, what's the min value, what's the max value, which can be used by the optimizer to like build better query plans and allow in general for better performance. And probably the most important part is the reference to a file. So those JSON files basically reference data files, the Parquet files, and say, okay, for this transaction, like some data was added and there is a new Parquet file. And so when you're reading the table, please also consider this data file. Yeah, it's all transactional. So whenever you run an operation on the Delta Lake table, it's basically creating a new JSON file. And everything that happens within that transaction is basically stored in that JSON file. And if for whatever reason you cannot write that JSON file, your transaction is not valid and it's rolled back that like the asset compliance. And
so I dropped a link just for people that need it earlier, just on asset infrastructure, so they can understand that well.
Yeah. Okay. Cool. Yeah, there's some built-in optimistic concurrency control, which basically just says, okay, I've been reading version 8 of my Delta Lake table, and I do some updates, whatever, and I'm writing version 9, or I expect to write version 9. If there is like another transaction in between that has already written version 9, I will get an error. But in general, I'm not like, there's like no locking or anything. That's why it's like optimistic currency control. I just assume that there's no one else writing in the table at the same time, like modifying the very same data at the very same time. If it happens, we just get an error. But especially in batch systems, it's usually not an issue. And also, that's what I mentioned before, time travel capabilities. That's the Delta log makes it very easy to do this time travel things. I'll have some very basic examples afterwards, as well as streaming. So
perfect.
Just continue with that. if you ever had a look at the history of a Delta Lake table, it's basically like a representation of those JSON files. You can just get it if you like run a describe history. Then you see like the version, the timestamp, what kind of operation it was, some parameters, some metrics, who did it, and a lot of like auditing information that's just in there. So you also get like this auditing out of the box from the Delta log, which can also be pretty cool. So
Oh, that's nice. Yep.
Yeah, we have like customers that just like take the history and like persist it somewhere, and so they know forever whoever modified a particular table, because like this history is cleaned up usually after like 30 days by default. Yeah. So how does it work when you're reading a file or when you're reading a Delta Lake table? You see like the transaction log on the right side. The first thing that happens is the engine tries to find this last checkpoint file. Last checkpoint file is basically every 10 transactions, a parquet file is created that basically contains all the transactions before it. So in this case, this checkpoint file for transaction 10 includes all the transactions from JSON 0 to JSON 9, basically. Okay. And that's just to speed up processing, because if you would imagine you have like million transactions in your table and you would have like a million JSON files, it would not be really fast to read those million JSON files. So instead, like those are like condensed and aggregated into the parquet file, and then it's much faster because you just read like the parquet file or the checkpoint parquet file and all following JSON files. So it's reading the last checkpoint file, reading all the transactions that occurred after the last checkpoint file. So in this case, like transactions 11, 12, and 13, combine them and basically return the results. So that's why it's much faster compared to traditional Hive partitioning, where you would need to scan the storage subsystem for the existing data files, etc. So here we just have like one single entry point. They're reading a maximum of 10 files, like the checkpoint file and 10 individual JSON transactions, and that's it. And then you have all the necessary information to build your data.
It always amazes me that people come up with this, because it's such an intricate machine that like really squeezes out every drop of performance when it comes to accessing data and storing it.
Yeah, I mean, it all comes from problems that you usually encounter when you're working, especially with bigger amounts of data, where like scanning the storage system, or like even running like a list API call against the storage system takes ages, or it's just super expensive, for example, because you're just running so many of them. And this way, it's much more lightweight and scales much better, because regardless of whether you're reading like 10 files or 100 or a million files, it's still the same amount of metadata files that you need to read. Right?
Exactly.
Okay, so I think that's the most important part now of the presentation. I will just go through some very basic examples on DML operations, like an update, an insert, and delete, and then what actually happens under the hood, and how they are processed in Delta Lake. Okay, so let's assume we have like created a table. We have like those 3 rows, and we store it as a Delta Lake table. So the first transaction will basically be, okay, to my new table, there's like the schema in there. We also add a new file, a new parquet file, the part01, which contains those 3 rows, right? That's pretty straightforward. We have one file, and that's basically our table. But what happens now if I run an update on that table and change the price of the PC from 1,500 to 1,300? So what you would usually expect is you kind of like update the data that's there, right? But that's not what's happening in Delta Lake. Instead, what's happening is like you're creating a new file, and that's basically like reading the old file, updating that one row in the result set, and like storing it as a new parquet file. Okay, and then in the log file, you're basically logically removing the old parquet file and adding the new file.
Uh-huh.
Okay. So that might not be very intuitive, but that's how it works. But as you can already see, like you basically now, instead of like storing only 3 rows, you're already storing 6 rows because you have the data twice physically.
And that's how you keep all the time travel, essentially.
Exactly.
Yep.
So let's see the next case. When you're running a delete, it's awesome. It's like getting rid of data, right? We remove something. Not quite. So again, what happens is it's basically creating a new file. It's creating a new file that only contains the 2 rows that are still part of the most recent table, like without this the row for the PC. Again, for the transaction log, we're removing the old file and we're adding a new parquet file. Okay, so even if you run a delete on a Delta Lake table, it's actually creating data. So if you think of it, and you like your boss or your IT department comes and says, yeah, you're consuming so much data, and you say, yeah, no worries, I just delete it. That will not work. So that's not the only thing that you need to do. I mean, obviously you can do that, but there is some other mechanisms that you need to be aware of, because a simple delete will not actually delete data, but potentially create new data or consume more space. And yeah, the new created file just has those 2 rows in there. For a simple insert, that's pretty straightforward. It's basically just adding a new file with that 1 row that you're insert, or like the number of rows that you insert, obviously.
Yeah, curiously, okay. And it again, probably getting into a potential further slide that's coming down the pipeline from this, but I'm sure there's a potential issue with some of this stuff, asking from a probably a viewer perspective of like ending up with thousands, tens of thousands, millions of files on one of these things if it's a large table getting a lot of updates. So like exponential growth potentially if there's not probably some amount of file management.
Yeah, I'll come to that later.
Perfect.
Like in 2 slides, actually. Yeah. Okay, so but that's like the general way how Delta Lake works. It's in general it's like an append only system, storage wise. Whatever you do, it's you never touch any existing file. Those are like immutable. Okay, so even, as I said, like even a delete creates a new file. So obviously, these can lead to a lot of orphaned files and a lot of space and storage being consumed, because like every operation basically creates a new file. Okay, there are some exceptions, obviously, which is the next part that we'll cover, which is file and storage management. So there are some tools and some capabilities that you can use. And the most important, especially with regards to like cleaning up orphaned data and orphaned data files, is the vacuum command. So if you run a vacuum on that particular table, it basically knows that for the most recent version, like those the files that are still active, like parquet file 03 and 04, those remain as they are, and all files that are not referenced anymore by the Delta Lake table, which have been logically removed, are now also physically removed using the vacuum command. Okay, so that's your weapon to fight storage consumption. Also, the vacuum operation is tracked in the Delta log. It says, okay, when it started is 1 transaction, and when it's ended is also 1 transaction. But that's mainly for auditing and transparency reasons. So it's not actually a transaction in that sense.
And always just to tie it back into, just to keep this both discussing on the broad topic of Delta Lakes in general, but like they're in Fabric exposes in the UI for a lot of the Delta or for the Delta Lake items or artifacts that are in there. The ability to do this and adjust the time windows basically just via the UI configuration.
Yeah, that's what you would usually do. That's what you actually have to do, which what I highly, highly recommend to do, to at least have like a weekly vacuum and optimized job running on your Delta Lake too, because otherwise your data would just grow and it run out of control.
I'll be curious of two. Well, one, there's a question from Donald that I want to bring up in just a second, but a question to you, because it's, as MVPs, we often provide a bit of the feedback on like designs, and I think a common one from experts is like what should be on by default, what should be off by default. Personally, I feel like anytime you're doing anything in Fabric where you're creating something that's going to be stored in Delta Lake format, I feel like as part of that initial configuration, it should prompt you to like, would you like to turn on vacuum, and here's why you should consider turning it on, because it's not enabled by default. It's a bit hidden to find, and as you just said, you highly recommend it most of the time. I would, from my limited knowledge, I'd say the same for me, but I think they should find a way to make it easier to do it automatically, even for novices, and encourage you to turn it on, and the exception should be off, not the other way around. It also would save Microsoft money on storage, but I would be curious to know your opinion.
Yeah, same. So, like back in SQL Server, you had those maintenance plans where you could like schedule like a rebuild index and these kind of things. I would hope to have like something, maybe not automatic, but at least like easily accessible to everyone, to every Fabric developer, to easily control these kind of things and say, okay, like for each table, run a vacuum, and then like schedule that task on a weekly basis, for example. Databricks has something like this built in with I don't know what the actual feature name is, but you can turn it on, and then they magically manage this for you somehow. I'm not sure how it actually works. But yeah.
If you have a moment, I want to bring up a question from Donald just on this, and I'll say is I forget the other MVP's name, but it's a quote of like a good question is one on topic, but the best question is something that is answered at an upcoming slide. So like this might be actually coming up, but he's wondering like, would Delta Lake not be a good format for transactional databases that would have many changes per second? This dips back to a few slides ago when you're talking about how every single change is not an override; it's a new file. Depending on when it's done. So
if you really have like a transactional system, I'd not recommend Databricks, Delta Lake. And because it's not what it is built for. What it might be built for in that scenario is like for streaming, like if you have like updates and you want to stream them into the platform and just store the updates as they are in like kind of append only fashion, and then process them later. That's something that you can do, but I would definitely not recommend running like an update every second or every 100 milliseconds or whatever. Just wouldn't work.
Now, one thing, just to paraphrase, and at least in my universe, to try to tie it back to Fabric type stuff, it's like if you did have a transactional database, we now have SQL databases as an artifact type, which is stored in just traditional SQL storage designs, not Delta. But like you could have that, and then you could simply have a scheduled refresh going into a warehouse lakehouse in a Delta format that wouldn't have nearly as many files if it's only refreshing, say, once a day or something like that. So like you'd stage it between your bronze, silver, and gold, and that would be a very acceptable design from a medallion structure to be able to do that and not cause a lot of bloat that would require heavy vacuuming and other stuff like that.
Yeah,
cool. Perfect.
That's probably something I would recommend for these scenarios as well.
And just a last quick question on vacuuming and all this other stuff. Well, not even a question, but a comment from James. And considering you're over in Europe, you can probably answer this better. Is how does the without vacuum on and the fact that data is just kept forever and potentially, how does that relate to GDPR compliance if it's never deleted?
Yeah, so it's basically the same as for every other database engine. Ideally, that's at least my very personal point of view. Ideally, GDPR relevant data never enters your data lake or your lakehouse, but is kept somewhere outside, and you only have like references from from the lakehouse to that data, and the GDPR relevant and sensitive data is stored somewhere else. And like once some user requests like deletion of his data, you basically just like throw away the link, and then you just have it very anonymized in the lakehouse. But it's not reassociatable with the original user. But again, like very much depends on the data, and probably also on your like say lawyer, and then how he or she interprets GDPR, and yeah, how this has to
True.
be managed. But yeah, in
Okay.
general, like GDPR is a huge pain point when it comes to analytical platforms in general, I would say.
Yeah, fair.
What you
PII
could,
information, so on.
yeah. But what you could technically is you could run a delete for that particular user, let's say, and then run a vacuum afterwards, and then it's physically deleted. But that's usually not what you want to do on a daily basis. If you have like a multi-terabyte table and you do that, and you basically get rewriting that table every day, just to be GDPR compliant, you'd probably be better in like finding some other solutions like this anonymization approach that I just explained.
Exactly. Cool.
Okay. Yeah, so let's continue on the slides. So vacuum is very important. What you see now is basically we end up with those two files, and you might have heard of this small file problem. So Spark or processing engine in general not very good, like at reading tons of millions of small files, but rather read like one big file. Okay.
Yep.
And what you can do for this to be more read performant is using the optimize command. So what the optimize command does, it's basically merging smaller files into bigger files on the very high level. So it's like reading those two files and combining them into a new file, and storing that along with the existing file, like same pattern again. Those files are physically logically removed from the delta log, and then the new file is added using that add property. Okay. And this way, the read performance will usually go up for that table. Again, I mean, that's a very, very basic example on how this works. Just imagine it on a higher scale, obviously.
So curious on this is the like, I mean, it sounds like this marries it does marry well together with vacuum. As you have both the optimized and vacuum, you have a file reduction of the data you currently have, and then the vacuum of the data you wouldn't. Obviously, the more you optimize combine the files, the less stale files there will be to vacuum. So, and again, coming from my limited knowledge, I would imagine they would always work well together. But like, is there actually a downside to like having the vacuum be less performant at its job, because now that there's bigger data files with more breadth or depth across them, they're more likely to become active rather than inactive. So is there ever a downside to having both on versus just you should turn both on?
No, you usually always have both on. Usually you run the optimize first and then run the vacuum. That's the most common approach, I would say. So unless you have any very specific requirements, that's what I would do, like having a weekly job that runs an optimize and that also runs a vacuum afterwards.
Can you actually specify which comes first in Power BI, or does it do it automatically optimized in vacuum if you have both turned on?
In Power BI?
Sorry, in Fabric.
No, you need to do it manually, so it's your choice. Just like as you would run a select on the table, you run an optimize on the table and a scheduled interval. Then afterwards, and a vacuum.
And you recommend the schedule, optimized then vacuum, not the other way around.
Yes, because like as you see here, you already like created two new orphan files, like the files 3 and 4. And if you have a vacuum afterwards, you would already like remove those, like on a high level again. There is some retention periods and stuff, so this would not be the case in that very same example. But in general, like an optimize can create vacuum files, and especially if you have it run on a weekly basis. Ideally, the vacuum cleans up the orphan files from the previous week's optimize. The default retention is 7 days.
Yep.
Okay. So we have seen before that whenever you run like a delete or an update, it's kind of like very inefficient, right? Because it's like rewriting the whole file or parts of the file, and it's still consuming like a lot of space. So the guys at Delta Lake came up with the concept of so-called deletion vectors. So instead of like physically deleting the row from a particular file and rewriting the file, it's just like a deletion vector that says, okay, a particular file or a particular row in a particular file is marked as deleted. Okay, so
Yep.
from a delta log perspective, we are like logically removing the file, but we're also adding the very same file again. So we're not rewriting the file, but we're adding it again with the additional information of the deletion vector, saying that row number 2 in that case has been deleted. And this information is stored alongside with the Parquet file as a deletion vector file. And then whoever reads the file reads the Parquet file, reads the deletion vector, combines those two, and like removes the PC row in that example before returning the data frame to the user, or the results to the user.
Okay.
So that's like if you're running like very frequent updates and merge statements on your data, you should definitely turn that on. I think by now it should also be supported by all engines in Fabric, because I know in the past, like on signups and serverless SQL pools, there were times where deletion vectors were not supported, but you also didn't get an error message. So you basically like deleted the file, deleted the row, but when you read the serverless SQL pool, it would still just read the full part 02 file and return like 3 rows instead of 2, because it would just ignore the deletion vectors. I think nowadays they're just working fine with all the engines in Fabric, and they are, if I'm not mistaken, supported by all engines.
Okay, so like universal adaptation for that.
Yeah. So that's like the main feature that you should use when you have a lot of merges and updates. Just turn it on. So there's a table property like enable deletion vector, set it to true, and that's it basically.
Okay.
Cool. Yeah, because you mentioned it a couple of times before, the time travel, and I said like that's like kind of like leftover kind of thing of the whole way how Delta Lake works. And it's actually pretty simple. So if you run a select on that table, it takes all the JSON files, evaluates the remove and the add, and checks what files are actually active for the most recent version of the table. Finds out, okay, it's Parquet file 3 and Parquet file 4, and these like 3 rows, right? If you run the same and want to see like version 2 or version 1 or any version basically that exists, it's just only reading up until that version, basically just ignoring in that case the version 3, like the addition of that 1 row. So if you run the select star from the Steam product table version as of 2, it will only consider transactions up until version 2, right? I'm just ignoring the insert.
Okay.
But that's pretty straightforward actually, right? And instead of version as of, like that specific syntax, you could also use timestamp as of. So if you want to jump back to a particular point in time. Okay. Obviously, this only works as long as the files that have been modified back then are still there. So it could be that like a file was orphaned and it was vacuumed and it's not there anymore because you want to save storage space. Then obviously you cannot just magically go back in time and see how was my data back in 2020, for example. That's not working.
Yeah.
Well, unless you configure it that way and then you deal with the storage cost, you can do that. But it's also not recommended.
So essentially, like set the vacuum in theory to however far back you might want to be time traveling if you were wanting to use that feature.
Yeah. So now a question that usually comes up in that context is, should I use this for historization and like replace like STD2 dimensions and these kind of things? And the answer is definitely a no, because it's a different use case and it should not be mixed with those business requirements, let's say.
Okay.
Yeah, some more information on the vacuum and the optimize. So vacuum physically removes the files. Freeze the storage. But what's important from an understanding point of view, even if you run a vacuum for the last, let's say, 7 days, it's not deleting data that is older than 7 days. That's not what it means. Just like delete orphan files that have been logically deleted already and that are older than like 7 days, for example. Yeah, for the optimize, we mentioned it collapses smaller files to bigger files. You can also additionally provide some clustering and ordering options, and it's in general used to improve the query performance. Yeah, skip this. Something that I haven't mentioned yet is restore and clones. So that's also some very, very cool features, not used very often. Similar to doing time travel, you can also do a restore. So let's assume you have like a data pipeline and it's running through fine at night. And then you realize something is wrong because you deployed some new code and the data is actually wrong and you need to roll back. You can just use like the restore command and say, restore my table to timestamp or version as of like midnight the day before. And it would just like have like a metadata operation, logically removing the new files and making the old ones active again. And it's super fast. It's not rewriting any data. It's just metadata, as I said, and easily allows you to roll back some particular transformations, for example, right? Same for clone. You can create a clone of an existing table, and once you have cloned the table, you can basically operate on top of that table. There's two types of clones. There's shallow clones, which is just like copying the metadata and still like referring to the original data files. There's also a deep clone where you can where you also physically copy the data files. In both cases, you're independent of the source data. So if you want to try some operations on data and you don't want to mess with the production table, just create a shallow clone, for example. And every operation that you run on the shallow clone, even a delete or an update, it would just be persisted in the shallow clone. And it will not affect the underlying table.
So to think this back to like a Power BI maybe comparison, would this be kind of the difference of almost like just copying the metadata layer at a moment in time versus the like metadata plus data itself of like whatever the last refresh was in terms of like doing versioning?
Actually, like the metadata and the reference to the data.
Yep, with the deep one.
Clone.
The shallow clone. Okay.
Both. The shallow is just like basically copying the transaction log, but the transaction logs still refer to the data files in the original location.
Gotcha. Okay.
So that's doesn't consume any storage, basically.
Yeah, because I'm assuming it's drops of water in a pond for the access links.
Yeah. Yeah. So again, you can run the restore. Restore is also a transaction, so you can do a restore of a restore of a restore, whatever. And same for deep clones. Especially for deep clones, there is another feature like incremental deep clones, which can be very convenient if you want to like create snapshots, like daily snapshots, for example, of your data, or want to do a backup. And that's super efficient. They're like copying the data files that haven't been copied yet. And we had a customer and we did like a backup of a 50 terabyte table in like 1 or 2 hours, I think. initial one, and then like the incremental ones were just super
Wow.
small,
Okay.
and were like, I don't know, like a couple of minutes basically. Because it also can be distributed across and parallelized on the Spark cluster.
Yeah, that's impressive if it can fit that much data in that amount of time.
Yeah. Yeah, because you just have like, I don't know, like 100 nodes or 20 nodes or whatever size of your cluster, and it just copying the files in parallel.
Yeah.
I also briefly want to jump into streaming because I think that's one of the coolest features of Delta Lake. I know we're running short on time already. I'd like to cover this at least.
Sure.
So every Delta Lake table can be used as a streaming source, and what happens is that it's basically reading the files as they were recorded in the transaction log and exposing them as a stream, and then you can do all the transformation that you want to do in the stream, and then write your data in the target location together with the so-called checkpoint file. Not to be mistaken for the checkpoint file in the Delta log, but for a checkpoint file for the streaming. And that basically stores the version of the source Delta Lake table that has already been read. So for example, if you have a stream and it started and you read until version 10, and then there are some operations on the original on the source table, and you start the very same stream again, it would automatically know, okay, it has already read everything up until 10, so it will only read from transaction 11 onwards. So that's a super easy way to actually build some Delta logic on top of Delta Lake. And you don't have to like run a mux on the target table on the like modified date or load date and then filter the source where everything is older than or newer than the last date that we have already loaded. So that's very efficient, and especially on the lower layers in your lakehouse architecture and your, let's say, medallion architecture, that can be super convenient, a super nice way to load data from bronze into silver, for example.
Excellent. Yeah.
Yeah, so I also use
Points.
this approach to do some batch processing. So I basically build it as a stream, but just start the stream once a day. And then you get like the same semantics as a batch job, but you could just also execute it like every hour if you want to. You don't need to change any of your code, and it automatically knows what has to be processed. And it might be that if you run it on an hourly basis, there might be no changes at all, and then it will just finish in a couple of seconds. Okay, change feed. Let me cover that, and then I guess
Okay.
we can have some questions also, hopefully from the chat. Your change feed, you can, similar to SQL Server, you can enable a change feed, which will then track each individual change. Like when you run an update, it will store a row how it was before the update and after the update, and you can just read it as it is, as any other Delta Lake table. So it's also stored as a Delta Lake table. And it's actually super lightweight because it's not adding too much. It's not consuming almost no additional storage. Let's put it like that. But yeah, that's for the change feed. I would have some features that have been recently added, but I guess we can jump to some questions.
Yeah, so a couple more comments, not necessarily a question, but I did like Donald's comment here. Like Delta in some ways kind of seems like Git for data because it's files and branches and everything else in a similar Git structure.
At some point, yes. If you want to do that comparison, you might also want to have a look at a project called Nessie. I think it's from Dremio, which also allows you to do cross-table or multi-table transactions in a Git fashion. I haven't had a look at my own yet, but it looks pretty cool. And especially like this comparison with Git, because that's the very same way you can then like create a pull request for your data. and then someone approves it and these kind of things. I think that's pretty cool.
Is the Oh, okay. I was relaxing. Yeah, for some reason it like the comment doesn't cover up our names, but it gets rid of our names when we when you put it on the. I'm assuming it's probably because it expects like a square panel of like more than one person. That's interesting.
Yeah.
And one other just again like between James and Donald, there's a few good comments. So he's apparently also seen the change feed has been used to help with slow changing dimensions as well.
Yeah, it basically exposes all the data that you need for a slowly changing dimension. I have to admit that more recently I'm not really using this. Well, no, that's not true. The way I usually record changes or track historical changes on the lower levels in Lakehouse is usually just like taking the change feed and storing it, right? There is like, and at any point in time you can just like filter on like ingestion time less than the time that you want to have, or the time frame that you want to query, and get like the latest row for each business key, and then you get like that state of that table at that point in time. That can also be used to easily build up your STD2 dimension, for example.
Okay. Yeah, and actually on that note, like are there any other unique use cases that you've found that are like not like an advertised benefit from having this type of structure, or like this could be related to the logs, the time travel, file structure, but is there any almost like hidden benefits that you found using this stuff over the years that has really come in handy with this type of data storage design?
Yeah, for me, I think it's really the streaming aspect of it, which solves a lot of traditional problems when it comes to regular data loads, where some of them fail and some succeed, and then you have to manually take care of the individual tables that failed, and you never really have like an overview or an overview of what failed and what not, and you need to manage it manually. And if you use like the streaming approach, just like start it and just read what's there. I mean, there can still be issues, obviously, if something breaks the stream, like a schema change, etc.
Yep.
But it's more resilient. You can just restart it, basically.
Okay, no, yeah, I would agree on the streaming aspect. Is a very powerful feature for that for sure, and the overall like storage cost comparatively, both for transfer in and out, is drastically improved over traditional database design. I'm glad Microsoft's decided to fully embrace it for sure.
Yep.
I did notice no other comments at the moment, but I didn't notice you had a conclusion lessons there. Were there any other remaining things that you wanted to cover as part of those last couple slides, or?
Just switch that back. Yeah, no, so as I said, like, I think we mentioned that it can solve a lot of problems that we had in traditional Hadoop environments with the Hive Metastore. It's very important that's why I focused a lot on these individual transaction types and DML statements like the update and delete. And that you just understand how it works under the hood and how it's actually consuming your storage. I mean, there is some good reason. I hope you now understand why it is that way, and it gives you like those features like time travel and restore capabilities, which are also pretty cool. And
absolutely,
especially nowadays, where storage is usually not a big bill compared to the processing.
Yeah,
it's a no-brainer to turn it on for at least for like a week, which is also the default, so that you can always jump back in time and see how your data was and roll back. Yeah,
exactly. I mean, as you just said, like these days, I mean, even with the Fabric capacity, it's like the primary thing you're paying for is compute. It's the it's
exactly
processing and retrieval. It's pennies on the dollar to storage large amount of data in a cold or warm format. It's just how often do you use it.
Yeah, I think a terabyte, at least in Data Lake Store Gen 2, on hot tier, I think is 30 euros a month, which is like,
Yeah, exactly. It's like
if you
nothing.
spin up a cluster, that's probably like burning more in an hour. So,
It's true.
yeah. So I try to have like more data stored than having like complex and resource intensive like processing jobs to get the data in the shape that I want on a regular basis.
Yeah, that's fair.
Yeah.
I think that was the only. Oh, there was one more. Sorry.
I have one more
There you go.
for just some references. So everything
Yeah.
about Delta Lake, you can find on Delta IO. There is some good like online book by Jacek Laskowski. The link is there. And also, if you want to dig into the details, I also added the link to the actual protocol that describes the structure of the Delta log and how the JSON is built up and what's in there. It's really nice to have a look at if you want to dive into that. And as I mentioned, there's also like a huge Delta Lake community. For myself, I'm very active on the Slack channel. You also find the links on delta.io. There's like a community section or something, and at the very bottom you find a way to a link to join the Slack. It's open, it's free, and yeah, if you're working with Delta Lake on a regular basis, I'd highly recommend that. Even if you're not asking questions, and you also learn a lot by just reading other people's questions and answers, obviously.
Sometimes just being a wallflower, fly on a wall, and you still learn quite a bit for sure. And I dropped all three of your links that you just mentioned into the chat for people as well.
Yeah. Cool.
Excellent. Now, this has been very informative, and I like deep dives. I think from an exploratory perspective, just to help show you like some of the benefits if you're considering migrating to environments that let you do this. Really gonna, I think, help people understand why they might want to put the effort in to actually move. Pay the initial upfront cost, so to speak, of whether or not it's time or money, but all these extra added benefits that come with it. But I think the big one that in the Microsoft universe definitely is, excuse me, underutilized from a business intelligence perspective is certainly the time travel, because it's there. It's just outside of professional backend tools. It's not easily exposed for the semi-pro developer type environments and that stuff, and certainly off of reporting, it's just not accessible at all yet. So fingers crossed that someday that becomes easier.
I think at a SQL endpoint you cannot control this at all. It's just always reading the latest version, if I'm not mistaken. So yes. Yeah, so that's like some data engineering feature, I would say. But
yeah, 100%. Yeah, really only accessible through external tools or notebooks, or third-party tools plugging into it, or notebooks and things that wouldn't be using something besides just a standard SQL endpoint. But we're still early-ish, in the development cycle of that platform. So something that I'm sure we'll get as a birthday present someday. Yeah,
maybe.
Fingers crossed. Like I'm optimistic, so I'm making a declarative with a hopeful intent. But as always, Gerhard, this is fantastic to get you on to walk through this. It's always a good deep dive, and I certainly learned quite a few things along the way on this, and help to sharpen the edge on some of the tool sets a little bit. Otherwise, any closing remarks before we wrap up?
Yeah, maybe like if you haven't tried it yet, I'd definitely recommend just try it out. We're probably already using it anyway, because nowadays it's the default for Fabric. It's also the default for Databricks. So unless you do something very specific, you're probably already using it anyway. And I hope you just get some more idea on how it's working and some additional capabilities that you might haven't been aware of before. And you might want to explore those for your future use cases and scenarios, right?
True. Okay. Yeah, and exactly, like as much as possible, like play around with this stuff, like get your hands dirty a little bit. And usually the best way to learn. Certainly that's how I'm able to poke around on that. And thankfully, at least, like again, going back to the Microsoft universe, is you can create a lot of Fabric items with demo data that will populate it into Lakehouse's warehouses, let you play around with these files, see what like vacuuming and optimization would look like, so that there is at least some friction removed on getting some data into there if you want to explore like what the structure would look like within the Microsoft universe if you're not going to Databricks directly as a platform.
Yeah.
Cool. Well, then I want to thank you for taking your time for this out of your Thursday evening to be on, and I'm sure we'll have other opportunities again to get you back on in the future to talk about
Sure.
anything in the Microsoft universe. So always a pleasure, and hope you enjoy the rest of your night, and looking forward to seeing you next time. Or actually, just speaking of, will you be at SQL Bits this year?
No, probably not. Mainly for family
Then
reasons.
yeah, no worries. Well, at some point we'll bump into each other again, of course, at a conference.
Yeah,
But
sure.
yeah, enjoy the rest of your evening, and everyone tune into this. Enjoy the rest of your morning, afternoon, evening, or night as well.
Yeah, cool. Thanks for having me, and goodbye.
Absolutely. All right, take care.